The topic I selected, dynamic analysis for looms industry, because Professor Darsan Mehta said me that it is about recent advancement, and I had a lot of experience in design of such industrial building, and I have come through many problems they are suffering. Problems defined by clients, problem defined by various consultants, engineers, and really it is a very problematic area. Later we will see much in depth what are the different parameters we have to consider while designing any industry which is housing the looms inside. Okay, I have seen many buildings which are really performing very well and many buildings which are not performing very well. Both categories of the buildings are there, and a lot of criteria it depends on. Okay, so we will have little bit inside of this in this 1 hour. Okay, and there are so many papers I have published on this uh, looms industry. You can Google it and you can get it uh, from Google search bar. Okay, so let us start with dynamic analysis for looms industry. Very first statement I would like to mention over here, mentioned by Albert Einstein, that everything in life is vibration. If no vibration is there, nothing is going to exist. Many times we are speaking, also we are speaking English, Gujarati, Hindi. So we speak like that we are speaking in English or in Gujarati, but it is actually frequency. It is of different frequency and we are able to hear in a different way. Okay, so everything in life is vibration. We are dealing with and thread into the text. It is central point of whole processing for the cloth production. You know that there's a yarn manufacturing is there, dyeing and printing is there. The end process is dyeing and printing. Okay, so this is central pillar. If yarn is of not useful if we do not weave it. Okay, so weaving is important, and dyeing machine cannot dye it without having the cloth piece. So this is a central pillar of this entire manufacturing process. So, and it is the most vibration creating machine, okay, in the looms industry. It is available in various sizes, right from freestanding handloom to automatic mechanical tool. Okay, so we have also seen handloom. All of you might have come across this handloom machine and automatic machine. As we are in the Surat city and we are very much fortunate enough to have exposure of these machines. So when we talk classification of loom, there are broadly two categories, handloom and power loom. We are mostly worried about power loom because it is high speed machinery, so it is creating more effect on the building in terms of vibration. So in further in depth, if handloom is the vertical loom, pit loom, frame loom, chitranjan loom, okay, these are the different category of handloom. Power loom, conventional power loom, it was very much common before. Right now also it is very much common, but people are more now opting for water jet machine, rapier machine, okay, creating different types of. Just so this conventional power loom machine also we are coming across in this Surat city, and nowadays proportion of this water jet machine and rapier machine is also increasing a lot. So this is about classification of loom machine. Now when we talk of analysis, dynamic analysis of the looms industry, always structural analysis consider two aspects, static aspect and static component is there and dynamic component is there. So in static component, everything steady state of load is there, gradually applied load will be there, and it is not time dependent. It is not time dependent. So that is static component. We are considering steady load, steady state of the load, or it is gradually varying load, and it is not time dependent. But when we talk of dynamic component, it involves the motion of the particle, suddenly applied load, and it is time dependent. So we are considering this component when we are talking of dynamic analysis of the looms industry. So static component will consider only dead load and live load. and it is very good, very well mentioned in the IS 875 dead load and live load. You can calculate from available IS code, latest IS code, IS 875. And dynamic component which involves the motion, suddenly applied load, and machine vibrations like earthquake load, wind load, and blast loading. When we consider all this loading, we have to go for dynamic analysis. Uh, so that is what about static and dynamic analysis. And when we talk of structural response, what do we consider? Deformation behavior of the structure subjected to particular loading. I have experienced many times when I'm visiting looms industry. You will feel vibrations. When you are sitting on the chair, you can feel in a particular direction at a particular time you are getting certain vibrations. Even box which are there in the industry, you can see vibrating them because it is highest vibration creating machine in textile industry. So dynamic component, when we consider displacement, rotation, velocity, and acceleration. We are very much concerned about acceleration part of the building, velocity, rotations, and displacement. These are the dynamic responses of the structure we are supposed to study while doing the analysis. So what are the important parameters for performing dynamic analysis? What are the important parameters? First one, whenever you do any dynamic analysis for industry, you must know the operational mechanism of the device, the machine, how it operates. And without knowing machine, we decide forcing function to you in dynamic analysis. Then we talk of natural frequency, we talk of resonance condition, tune condition, deformation in terms of displacement and rotation, and vibration isolation. All these aspects I will cover in my presentation, except last one. If time permit, I will go for vibration isolation also. I have very good, excellent example of practical example of vibration isolation we are practicing in our Surat city, and what is the problem with that. Okay, so this last component I'm not sure about the timing, but above all these components which are necessary for dynamic analysis, we will go for that. So before starting with, let us understand the operational mechanism of the device. So this is what actual photograph of the industry. You can see the machine, very small space is there for movement of the person. Most of the space, 90% space is covered by machines. Okay, and in a single row, there might be a 6 machine. In this row, there might be 6 to 8 machine, and in this also there will be a 6 to 8 machine in a row. Okay, so they are mounting about 12 to 16 looms in a, depends on size of the industry, but there might be a minimum 12 to 16. So this is the actual photograph of the looms industry, and this is the machine we are installing. They are available. The different manufacturing companies are there. Different brands are available. But simple operational mechanism is same of all the machine. And this is simple. Our conventional power loom. Conventional. It is not water jet. It is not air jet. Okay. So this is what actually mechanism. There is a beam over here. Yarn. Yarn is passing through this all component, and thereafter here it will get separated into two different filament, and there is a shuttle. Okay, here. So this part is rotating part. What we call is lay. So what is important component in dynamic analysis? Being a civil engineer, what is the component? Important component is lay, which is moving forward and backward, and at the same time this heddle is moving up and down. And third component here you can see shuttle. So I will later explain you in 3D also. So lay is important, which is moving forward and backward. Heddle is important to just up and down, to make this filament up and down, yarn to make it up and down. And for shuttle is for inserting cross fiber, so that we can have a cloth piece ready over here. Okay, so this is raw material. Yarn is available on this side. It will go through process of heddle, lay, and shuttle, and we will have finished cloth piece over here on this side. Okay, so this is actually process. The yarn is passing through this heddle. Heddle is moving, so reed is there. Shuttle motion is like this, and your lay motion is perpendicular. So this is reed motion. Reed motion is this one. This. Okay, this reed. Lay and reed is one component. Reed and lay is one component, which is moving forward and backward. So this is reed motion, and subtle motion is right angle to that. And because of that, we have the finished cloth piece over on this side. So two yarn, every fabric is having two filament right angle to each other. So one in direction, that is by reed motion, and another that is feed up by subtle. So another filament right angle is feed up by subtle. So we have two perpendicular motion, reed motion and subtle motion, and these are the two primary vibrating component in looms industry. Heddle is not creating much problem. It is very slow moving and mass is very less. And our Newton's law, F is equal to ma. So force depends on mass of the element. So mass is very less. It is just moving up and down. So it is not creating any problem. Of course, the motion of the lay and motion of the subtle is creating a lot of vibrations. So actually, reed motion is in this direction and subtle motion is in plan. This is plan view. So these are the filament which are coming from one end to another end. It is moving from one end to, and this are the two right angle motion of the component. And out of these two, reed motion is much bulky component, and hence it is inserting a lot of vibration issue compared to subtle motion. The mass of the subtle is very less compared to mass of the reed, and hence the vibration created by reed motion of the reed is really very important to study. So this is actually process. The reed, you can see it can move up and down. The subtle is moving in this direction, and this is actually lay, reed and lay component, which is moving forward and backward. So these are the three primary motion in looms industry. Heddle is moving up and down, subtle is moving along the length of the machine, and this lay is moving across the length of the machine. So these are the three primary motion: vertical motion along the length, and this is rotational motion. This is rotational motion about this point, So lay is moving forward and backward. So out of these three, I told that this weight of the subtle is very small. So it is not creating much problem of vibration. Even heddle is not creating any problem. The most important component is this one, the motion of the lay, which is moving forward and backward. And this forward and backward motion of the lay is creating problem like this. When your lay is moving in this direction, it will provide push force over here and uplift force here. Push and uplift. So this leg will be under uplift and this leg will be under push condition when it is moving in this direction. So this direction, when it will move in this direction, push and uplift. When it will move in opposite direction, and there will be a forward backward motion. There will be a forward backward motion. Okay. So when your lay is moving in anti-clockwise direction, there will be push on this side and uplift over here. What I mean to say, because of forward and backward motion of the lay, your leg will be under, in our technical term, either in compression and tension, alternate compression, tension, alternate compression and tension. So you can see this leg, when lay is moving in this direction, clockwise direction, it is under uplift condition. When it is moving in anti-clockwise direction, it is in push condition. So compression, tension, alternate forces are developing under the leg. That is what the operational mechanism of the looms machine, and we are worried about this motion of the machine. So this is what push and uplift. Here push and uplift, alternate. Okay. So that is what about we understood operational mechanism of the looms machine. Now, what is the effect of operation of machine in the building? Can you please let me know what will be the effect of this machine operation in building? What it creates actually? Anyone?
Vibrations.
Vibration. Definitely. We are very much worried about vibration. So that is actually your building is deforming because of such operation of the machine. It will move left to right. Even with the operation of machine, with the operation of lay forward and backward, it will push building also forward and backward. So you will observe vibration. Is it good or bad? Vibration is good or bad? Definitely in this application. Yes, yes. Anyone?
Sorry, sir, repeat.
Is this vibration good or bad?
If it is
Bad,
under
sir.
natural frequency, then it is okay. Otherwise, it is bad.
See, this vibration is always bad. I will share my experience with you, whether it is under resonance condition or not. We will see later if it will match with the frequency. You rightly answer it that if it is matching with the frequency, it is a problematic. But any kind of vibration, if you see in the building, I have seen the old buildings which were constructed in the good condition, where because of it was under vibration over the period of time. Over the period of time is 20 to 25 years. It has broken down the bond between different particle of concrete, means coarse aggregate, fine aggregate, and cement. You know, cement gel is bonding your fine aggregate with the coarse aggregate, and these vibration are always trying to break down this bond, and building is slowly weakening. Building is slowly weakening. That is the bad part of it, vibration. So it is actually undesirable activity. It is actually undesirable activity in the building. It is creating undesirable because yes. Please mute your mic, please. Someone. Fine. So it is an undesirable activity. But we have some good application of vibration. Vibrations, it depends on application, whether good or bad. Particularly for this problem, whatever we have. Yes.
10-15 पानं द्या, परत राहिलेलं देतो तुम्हाला आणून.
Excuse me. Please mute your mic. So it is for this application, it is undesirable activity. But some of the good application, you know, that breaker machine, we are using vibration for demolition of the building, compaction of the concrete, pile driving, even guitar we are using, and in that we are using vibration only for our achieving our function. Okay, and these are the bad applications. When in adjoining, I have seen in many areas that adjoining there is a railway track, and that motion of the train is creating vibration in building. Okay, so these are the some applications where we feel they are harmful to the building. So vibration and oscillation, what is the basic difference? That vibrations deforms the building. You will see deformation in the building, whereas in oscillation there will be a rigid body motion. You will not be able to see deformation in the component in the building. But vibration, when we say vibration, there will be a geometric deformation of the building. That is basic difference in vibration. Lay read is forward and backward. There is nothing to balance it. That motion, there is nothing to balance it. And when there is an unbalanced mass moving in the machine, it will create vibration in the building. Okay, and why it is creating vibration? Because your building, your machine is firmly attached with the floor of the building. Your machine is firmly attached with the floor of the building. So this forward and backward motion of the reed or lay, which is actually unbalanced, and it is creating vibration in the machine, and the same vibration we feel in the building also. So what are the different types of machine we come across? Rotary machine, reciprocating machine, and impact machine. These are the wide variety of this, which is rotary machine is high speed machine, reciprocating machine periodic unbalanced force you will see, and impact machine it peak very shortly and die out very quickly. Okay, and I have also mentioned about undertune and overtune. We will see later what is it. But this is rotary machine and reciprocating machine. So can you please let me know this Looms machine belongs to which category? The vibration what we observe, it belongs to which category? What kind of machine it is? Reciprocating machine and rotary machine concept is, I think you have undergone through it. I will not go much in depth, but you can see rotary motion of the wheel. Okay, so we have that motor in our, every house is having motor. Okay, we have for municipal water or whatever we want to just raise water from underground water tank to overhead water tank. We use motor, that is rotary machine. It belongs to rotary machine. and this is reciprocating your piston motion. Okay, piston motion is like, so your part is moving forward and backward. So our looms machine belongs to reciprocating machine. And how do we calculate unbalanced force? In case of rotary machine, we find out the force of amplitude F0 is equal to me omega square, where mass, eccentricity, and that frequency with which your machine is rotating. Okay, circular frequency. So that is F0, force of the amplitude in case of rotary machine. Similarly, for reciprocating machine also we can calculate, where you can see this part, this mass is moving forward and backward because of this rotation of the rotational component of this. Here lay is also moving in our looms machine, also lay is moving forward and backward because of some rotary component of the machine. Okay, so this mass is moving forward and backward, and this forward and backward motion of the mass is producing primary and secondary force. So how do we calculate primary force? How do we calculate secondary force? M omega square r cos theta and cos 2 theta upon theta. We will not go much in derivation of this, okay, because basically I want to give you practical application how we can analyze the looms industry using software. Okay, so that is how do we calculate force component. Why we require these equations? Because we want to define forcing function which can be utilized for analysis purpose. So this will help you in finding the forcing functions for analyzing looms industry. So this is basically your forcing function, Fp, force at any time equal to F0 sine omega t plus phi. So this F0 is nothing but forcing function. Okay, peak value of the forcing function. So that is forcing function. The force we can calculate by using this formula, and omega t plus phi. Phi is the phase angle. Phase angle will be useful in this analysis because we have multiple machines on a single flow. We have multiple machines on a single flow. So phase angle will be important for such analysis. Okay, so this is how we derive the forcing function for this looms industry. Now, one more concept we need, that is frequency, number of cycles or vibrations by the body during the unit time of the periodic motion. So that is frequency, our basic definition of frequency, number of cycles or vibrations undergone by the body over a certain period of time. That is frequency. And when we talk of natural frequency at which the system will oscillate without action of external force. There will not be any external. Of course, we require some initial force to disturb the body, but after removal of the force, it will go on vibration. It will go on vibration. So how many vibrations occur? The frequency at which the system will oscillate unaffected by outside force. Okay. So, and we find out this natural frequency by using this equation 1 upon 2 pi under root k by m. So this is the formula we use for finding the frequency. So you know that I will of the building, and stiffness depends on your size of the structural component, and that's why natural frequency can be altered by changing size or inertia of forces in the system. That is what it has been mentioned. So natural frequency depends on stiffness and mass of the system. And this is one practical example. You have seen this guitar where we have this string of different thickness. Okay, your guitar strings are progressively thinner to play the higher frequency notes. Why it is progressively thinner? You can see the thicker one on this side and thinner one on this side. So mass is different. Okay, mass is different. So when you're making it thinner, so mass is reducing, so frequency will be high. So you can use it higher frequency. We can have it higher frequency note using thinner strings. So that is very good example of frequency, what we can learn from this equation. And forcing frequency. When the body is in contact with the external source, there is always external source of vibration. Just like our looms industry, there is a machine inside and it is continuously imparting force in the building, and under the action of that force, your building is vibrating. So that is called forcing frequency. Continuously you are applying the force, and here also you can see this palm, we are moving up and down. At the same time, this mass is also moving up and down. So this mass is moving up and down just because of the moving of this palm up and down. Okay, so this hand is moving up and down. and because of that, this mass is moving up, and so this motion is called when we measure this frequency, it is called forcing frequency. This frequency is under the action of external force. Okay, it means that vibration is induced continuously by some other body in contact, and whatever frequency is occurring, that is forcing frequency. Simple, in a simple definition. So forcing frequency always occur in because of the body, other body in contact with. Okay, the other body in contact with, and because of that, forcing frequency is occurring. And the resonance condition, when we talk of, it is just matching of the two different frequency, natural frequency and forcing frequency, both are matching with each other. For example, your machine is having forcing, your machine frequency is set 3, your machine frequency is 3, and your structure is also having frequency 3. Both are matching, okay, exact matching. Then it will create the resonance condition. And resonance condition, what does it mean? The response of the structure will get exaggerated. You will see tremendous displacement in the body, rotation in the body. So that is what effect of resonance. Exaggeration of response of the structure. Rotation, displacement, you will see. So it is, see, when both the frequency are matching, it is actually additive. Addition of frequency is there. What does it mean? Both the body are moving in the same direction. For example, here, this mass is moving in downward direction. At the same time, this hand and this mass both are having same frequency. What does it mean? 3 and 3. So what happened? Both are matching with each other. So when this hand will go down, this portion will also go down. When hand will go up, this mass will go up. So both the body are moving in the same direction, and when both the body move in the same direction, there is an addition effect. Addition effect means exaggeration. Displacement will get exaggerated. Okay, so that is what effect of resonance. Speed is okay, no?
Yes, sir. Yes, sir.
Okay, okay, fine. So that is what about resonance condition? Now, tune condition, and this based on this resonance condition, we come out with the two different types of foundation, and that is called tune condition. Foundation type, it is relative situation of forcing and natural frequency. Now, what is this foundation type? Either we go for undertune and overtune foundation. Undertune foundation, overtune foundation. The problem what we are suffering in our looms industry because of undertune condition. Okay, overtune condition and undertune condition. So what is it? It is just a relation between two frequency of the structure and frequency of the machine. When natural frequency of the structure is less than machine frequency, and it is called undertune, and overtune when the frequency of structure is more than frequency of the machine. It is highly desirable that frequency of structure is more than frequency of machine. But what is the problem with that? Frequency of structure, if you want to make more, okay, you need to make the building more stiff. Then and then you can get more frequency. Now, when you want to try building more stiff, when you get frequency high, when you make the building more stiff, you know frequency 1/2 pi is equal 1/2 pi under root k by m. So if you increase the stiffness of the building, then and then you can get more frequency. Now, stiffness depends on mass of the building. So you need to add more and more mass in the building. Okay, you make the size of the structural element more larger one, that it can have more stiffness and more frequency. So it will result in uneconomical solution. So many times this undertune foundation is desirable because frequency of structure is less than machine frequency, and we can make the structure lighter one in context of economy. Size of the structural element will be smaller one, but the problem of vibration will be there. So we have to overcome both. We want to avoid vibration also, and we want to achieve economy also, being a structural engineer. So that is a difficult part of this analysis. So the foundation type, basically undertune depends on relative frequency of machine and structure. And this is the typical graph you can see in IS code, in book also it is given, the deformation response factor and frequency ratio. This frequency ratio, machine frequency and natural frequency. So you can see two vertical lines are there, 0.8 and 1.2. You can see the response of response factor. So when ratio is 1, means machine frequency and natural frequency exactly matching. Ratio is 1, you can see the response is highly exaggerated. But as you go away from that ratio 1 to 0.8 and 1 to 1.2, thereafter response is quite acceptable, What does it mean? Even IS code is saying that your natural frequency and machine frequency should differ at least by 20%. That is what does it mean, 0.8 to 1.2. Okay, so your natural frequency and machine frequency should differ by 20%. So this ratio, when it is 0.8, what does it mean? Your natural frequency is very large compared to machine frequency. When ratio is 1.2, your machine frequency is very large compared to natural frequency. Okay, and you can see from this graph which condition is highly desirable. The response you are getting less here. Highly desirable is undertuned foundation. It will give economy also and response also. You can see, you can compare both 1.2 value here and 0.8 value here. Response you are getting more in case of overtuned condition. Okay, so that is what understanding of this graph. So basic difference is your machine frequency should differ natural frequency of building 20%. Either less or more. Okay. So this is undertune and overtune, what we discussed about. Now what happens in undertune condition and what happens in overtune condition? We understood the difference of this. Undertune means your building frequency is less than machine frequency. Your building frequency is less than machine frequency. Now what happens? Suppose your building frequency is 2 hertz, okay, your building frequency, and your machine frequency is 3. Then what happens? When your machine will achieve frequency, full frequency 3, from 0 to 3, it has to cross 2 value. Okay, when your machine is under not in running condition, it is in switch off mode. When you switch on your machine, it will start from 0 and it will achieve frequency of 3. From 0 to 3 frequency, it has to pass the frequency of building, which is 2. And when it has to pass frequency of building 2, what happened? There will be a resonance condition. So you will feel some vibration in the building. That is what undertune condition. So displacement increases with the increase in frequency. That is what it does mean. 0, 0.5, 1, 1.5, 2. Now 2 frequency of machine matched with the building frequency. Now what happened? You will see displacement increase, exaggeration in the response of the building. Thereafter 2 to 2.5 and 3. So there will be for some time there will be a resonance condition and feel some vibration. What the undertune found is far away from machine. So frequency of building is 4 and your machine frequency is only 3. Your machine frequency will never reach to the building frequency. It will never reach to the building frequency. There will not be any problem of resonance, but it will give you uneconomical solution because you're making structural element very larger one to have a higher stiffness of the building. So that is what about undertune and overtune foundation. And this is how much amplitude of vibration, permissible amplitude of vibration. Okay, for disturbing frequency, for different frequency of the, it is given in IS 2974. This graph is given. So disturbing frequency from 0, 3, 5, 160 hertz, and amplitude of vibration in micrometers it is given. So what is permissible? So maximum you can see for all the graph, it is maximum is 200 microns. Okay, 200 microns. So ADD, different lines. All these different lines are for different purpose. Limit to avoid damage to the building, limit to avoid serious discomfort to the person, and limit to ensure reasonable comfort to the person. This is one of the experience given by client, that when your building is vibrating much, their laborers are not able to work properly because there's a vibration of building, there's a vibration of machine, and you want to do accurately work on the machine. The laborers are suffering problem. They are not able to work properly, and little bit disturbance in the body may create accident, because majority of the part in the this looms machine is rotating part. So if somewhere you missed out your accuracy and you may come across accident. So that is what the issue with. So this is what permissible amplitude given in the IS scope for different frequency of the machine, and that you have to justify. Very frankly, it is very difficult for looms industry, because we are installing looms at ground floor, first floor, and second floor of the building. And if you will see in machine foundation, they are giving. We will see later. We will see, but this value we have to justify. It is very difficult, and that's why mostly we are trying to avoid resonance condition, and we want to minimize displacement as far as possible. So this is a typical diagram of looms industry. You will see in Surat city. You can see here 2, 4, 6, 8, 10, 12, and 14 machines are there in a. So 7 in this row and 7 in this row. So there are total 14 machines in there. And these machines, they are installing at the ground floor level and at the first floor level, and some are installing at second floor level also, who are purely working with weaving process. Okay, so this looms machine, I told you that multiple machines we are housing in the building, and that is why it is really very tough to create different analysis file for this building. It is not like that one machine. If it is single machine, it is easy to analyze, but multiple machine will have different performance at different moment. Okay, and that is you want to club in analysis. Really very tough job, very tough job. But with the help of software, it is now possible. And but with the help of software also, you have to create multiple file for multiple complications. Okay, till now we have not added layer of phase angle. We have not gone through the phase angle layer. We will see later. Okay, so these all machines are operating on a single floor. Now I will explain you what happened, that all these 7 machine, the lay motion is to the left, and these 7 machines are having lay motion to the right. What will happen to the building? Can you tell me? All these 7 machines are having lay motion, read motion to the left, anti-clockwise, and these 7 machines are having lay motion, read motion to the right. What will happen to the building? Can you tell me? When I'm talking of read this portion, I'm talking of this. Let me go to this. I'm talking this. This lay motion is extreme left on this side here. And when this lay motion, your lay can move either counterclockwise or clockwise, forward, backward. So forward, clockwise, backward, anti-clockwise. This lay can have only 2 motion, okay? Forward and backward. So that is what I'm asking. When this lay is moving forward and backward, what will happen to the building? Here. And all these 7 machines are having lay motion in backward direction, and all these 7 machines are having lay motion in forward direction. These 7 are having counterclockwise motion, and these 7 are having clockwise motion. Definitely what happened? These 7 machine will force building to the right, and these 7 machine force building to the left. What happened? When left hand side 7 machine will force building to the left.
It is balanced.
Yes, it will be under balance condition. It will be under balance condition. But who will control this? No one can control this. Ideal is that we cannot say to the labor, 7 machine tara at a time to the, you have to run to the left, and this 7 machine you have to run to the right. It is the any control. What happened? All the machines are having lay motion in a particular direction, either counterclockwise or clockwise. What happened?
Condition. Then building will be tilted. The building would be tilted then.
Vibration created.
Maximum vibration you will feel. Maximum vibration you will feel either to the left or to the right.
Right.
Either to the left or right. But one more situation I would like to tell. One more situation I would like to ask you. This is central part of the building. All these 6 machines are having to the left counterclockwise motion, and these 6 machines are having clockwise motion. Then
that also is balanced.
These six machines are having lay motion in counterclockwise direction, and these 6 machines are having lay motion in clockwise direction. Then I'm not talking of these 2 machines, forget it. I'm talking of these 6 machines having left motion. Okay, all of them are moving to the left, and these 6 are moving to the right. Lay motion is to the right. What happened? Now you can visualize what will happen to the building.
It will induce torsion.
It will induce torsion. Torsion. It will induce torsion.
Right, right. Mhm.
Okay, the back side of the building will move to the right, and the front side of the building will move to the left. So now you can imagine what are the different situations we have to check while analyzing this Looms industry, and that is for dynamic. Static analysis, no problem at all. Dead load, live load, over, fine. But who will take care of this dynamic part? So these are the different, and that is where your phase angle comes into picture. Okay, phase angle comes into picture, and we have to consider that component, but we are not considering that component right now because it is too complicated. So we know that when all these machines are having lay motion to the left or to the right, it is the worst situation. In that case, you have extreme left deflection or extreme right deflection of the building. That is the worst condition. Okay, we are not considering about phase angle, because phase angle, when you introduce phase angle, it will introduce torsion. This will introduce only moment and displacement, means displacement and rotation, and this rotation is just because of moment, and displacement force. Okay, so this is what situation we are having actually practical. So this is practical plan. This plan is existing in Surat city, and this is what about ground plus 2-story building, ground, first and second story building. And this is the plane height of the building. Okay, plane height of the building, and they are installing Looms machine here, and some of the building they are installing at second floor level also. Now you can imagine the situation. Just now we talked about different variety of building, the building vibration for single layer. Now what happened? The machines are operating at 3 different layer, and that too in a different direction. Your lay is moving in a different direction. What will happen to this deformation behavior of the building? Okay, for example, all the Looms machine here, the lay motion is to the left. All the Looms machine here, lay motion is to the right. All the Looms machine here, your lay motion is to the left. Now you can see here your building will move to the left, in between left. Okay. Bottom story will go to the left. But this is again, I'm telling you that we are assuming all lay motion to the left or right. Now you can imagine all are moving in a different direction at different flow. All lay motion is in a different direction in a different flow. Okay, we need to scratch our mind how much analysis needed. Okay, how much analysis needed. So that is what about actual analysis needed, dynamic analysis needed. So while analyzing, this is the work done by one of my student, UG project student group. They have done the work. So what are the information needed for this building? We require size of the column, beam size, floor height, slab thickness, all these structural parameter we needed. What should be the thickness of the slab, floor height, longitudinal beam size. Longitudinal, when I talk of this beam, we have two beam. One is this one, longitudinal beam, and these are the across the length of the building. Okay, these are the different beam. Okay, so both the beam require longitudinal beam size, cross beam size, column size, height of the floor, and slab thickness we require. Material parameters, modulus of elasticity, we are dealing with the vibration, Poisson's ratio, density, and coefficient of thermal expansion. Okay, these are the parameters. We are not adding layer of expansion and contraction here. So these are the default parameter needed in software. Machine data you require. This you can bring it from machine manufacturer. Okay, size of the machine, operating speed. All the machines are having different speed. Okay, so you must know what should be the speed of the machine. Okay, and nowadays it is very difficult that we are in transition mode. I have seen many customers are switching over from conventional looms machine to rapier machine and water jet machine. You can imagine when machine you are changing, frequency you are changing, weight we are changing. So how that building will perform under that condition, and no one is taking care of. I'm sure that no client has asked to the engineer whether this building will survive for when we are installing different machine in that building. When we are switching over from conventional loom machine to water jet machine, whether it will survive or not. We need to perform again analysis and justify dimension of this lay, mass of this lay, and operating frequency. So these all data, see dimension of this lay, that is read and lay actually. Mass of this lay, it is about lay. Why we require this lay mass and height dimension? Because we want to find out forcing frequency. So this lay is moving to the left and right. So it has got some mass. So we have to perform this dynamic analysis. It has got length, it has got some mass which is moving forward and backward with some angle theta. So by using this data, we can determine the forcing function acting in the building. Okay. Self-weight and other than machine load, self-weight, waterproofing load, floor finish, live load, weight of the machine, and time history. All these parameters we require before starting with this dynamic analysis. Okay. Time history means your forcing function. Without forcing function, we cannot perform this dynamic analysis. And of course, weight of the machine and all this. This Looms machine is weighing from 1500 to 2000 kg. 1.5 ton to 2 ton weight of the machine is there. Okay, this Looms machine. Waterproofing load and all these are the conventional load we are considering, as we are considering in normal building. Okay, floor finish weight, etc. I would like to share one practical experience I hope I came through. That one practice started in the past, that what people were doing after casting of this slab, they were installing quota stone flooring, and on quota stone flooring they were installing machine. So on casted slab they were laying the flooring, and thereafter they were installing machine. But in between an era, okay, some advanced development in concrete development, people were using vacuum process. Okay, vacuum process. So what happened, they give you slab surface so finished that you need not to do flooring on it. Okay, you need not to do flooring on it. They give such a good finished surface of the slab. So this is what great advantage for the client, that we are able to save the cost of the flooring. Okay, we are able to save the cost of the flooring. So that is an added advantage. So the client accepted, and what happened, they started to install the Looms machine directly on slab without layer of flooring in between. So if you go to any old building, 20 or 30 years old, you will see there's a slab above, there's a quota stone floor, and above floor finish directly on concrete. Okay, vacuum concrete. So that is how it is advantageous or disadvantageous, we will see later. Okay, we will see. But this you keep in your mind. This is what practice going on. They may install Looms machine directly on slab without flooring. Okay, and this is what model you can create in. This is simply ground story model. Where you can see this is plinth and this is first slab, and how machines are installed on the floor. Okay, we create rigid link. Okay, so this height is actually height at the level of reed, where shuttle is moving. So we created this 4 rigid link to create the machine, and at this node, at this point, we are applying forcing function. F0 sine omega t plus phi. We have consider phi equal to 0, so it is F0 sine omega t only. Phi we consider 0 for all machine. Means all machines are operating in the same direction. That is what we presumed. Okay, and at this junction node of all these 4 digit link element, we provided forcing function. Okay, and under the action of this forcing function, how your building is performing, we are just observing 2 important parameter: displacement and frequency. Frequency is very important. We just want to avoid resonance condition. It means that whatever frequency of machine is there, it should differ. Your building frequency should differ 20%. It should differ 20%. Okay, your machine frequency is 2.67 that we calculated. So this is operating frequency of machine 2.67 we calculated. Mass of this lay, which was 15 kg, dimension of this lay and all this. Operating speed of the machine 160 rpm, and this is size of the machine. Okay, so these all data we could get from machine manufacturer. Okay, they provided us. Okay, and they are also not very much known about it. We have to visit their manufacturing unit, and we have to just measure the different element, and we have to this all data will not be available readily. You have to get it calculated. You have to get it calculated. Okay, so this is what data you can get it from manufacturer, and these are the default data live load we consider 2. Now you must be saying that if it is industrial machine, why live load you consider only 2? Because I am considering separately all the data of machine. Okay, so now I am not much relevant with the other load mentioned in the IS code, which is 4 or 5. Okay, live load. You know that maximum space covered by the machine, and the machine weight I am considering separately. Forcing frequency, I'm forcing the force exerted by machine is I'm considering separately. So no need to consider that. I'm considering only live load where labors are moving, the area on which the labors are moving. Okay, and the weight of the machine. Okay, 10 kilonewton we have considered. So this is what data we have considered, and this is what result we obtain. This is what we result we obtain. You can see size of the beam we adopted. Actually, there are so many tables. I have just given one table over here for your study only. And different column size. Okay, 918, 921, 924, 927, and 9/60 inch. If you talk in terms of inches. So beam size is constant and column size I am varying. So you can see frequency value is varying. Frequency value is varying. So what you can see from here, frequency is 1.2, 1.5, 1.7. You can see different frequency value are there. 1.47, 3.33, different values are there. Our machine frequency is 2.67. So what we must be taken care of, 0.8 into 2.67, 0.8 into 2.67, and 1.2 into 2.67. Your value must not be in this range. Your value must not be in this range. 2.67 multiplied by 0.8 and 2.67 into 1.2. So I think 2.67 this is into point is 2.13, and 1.2 into 2.67 is 3.06. I don't know the exact value. So any value, natural frequency of building, any value in between these two will create the resonance problem. So we can find out what are those values. What are those values falling in this range? It means that if this is the beam size and this is the column size, there is a problem of resonance. There is a problem of resonance in mode 3, mode 4, and mode 5. Okay, and we are not worrying about mode 3, 4, and 5. If it is ground plus 2-story building or ground plus 1-story building, if it is ground plus 2, we go up to mode 3. Okay, mode 3. So if it is ground plus 3-story building, you must think of what must be, and this is different height of the story. This is for different height of the story we have considered. So story height is varying, column size is varying, and this is the resonance condition. So definitely we are sure that if this is the column size, beam size and column size, your structure will be critical in mode 4. Your structure will be critical in mode 4. Okay. In mode 5, this height of the story will be critical. In mode 3, this height will be critical. This height will be critical. Okay. So this is very easily we can find out which size of the column is appropriate. Size of the column and beam is appropriate for particular condition of the machine operation in the building. Okay, so that is one study we can perform, and this is displacement study. So that also you can check it out, how much displacement is occurring But if you take care of this resonance condition, displacement will reduce a lot. Displacement will reduce a lot. Okay, so that is and here you can see same column beam size and column size. Okay, beam size is 1, column size is varying, and different floor of the height of the floor. So where displacement is larger one, it is in this case only it is minimum, and here you can see it is going maximum. We normally have a idea that if height of the structure is increasing, displacement will be more, but you can see even height is increasing beyond 4.267. Here displacement is less. Here displacement is less compared to here. Why here displacement is more? Because it is causing resonance condition at this situation. So it is not always so. In dynamic analysis, it is not always like that. When we increase the height of the structure, your displacement will always go on increasing. At particular height, it will be maximum, and thereafter it might reduce. It all depends on resonance condition. So that is what we require to control in our dynamic analysis. So this is what we can do with the help of software. Manually, I don't think we can perform, because we have to perform so many analysis, and then we can come to the conclusion which one is better, which one is not good. Okay. These are the mode shape. Mode 1, mode 2. You can see your building is just in twisting mode. This is in same direction. Okay. So mode 1, mode 2, mode 3. We can see one floor is going in this direction, another floor is going in this direction. So different mode shapes also we can have. We can predict the behavior of the building with such type of analysis. Believe me, in this analysis, the phase angle is still we have considered 0. Phase angle is still 0. Okay, it is not, we have not considered different phase angle. And if one want to study further in this, they can vary the phase angle also. Okay, so these are the different mode shapes we can have. Okay, we normally have that corner columns are very lightly loaded in static analysis, but in dynamic analysis, you can see the bending of column or twisting of the corner columns. In static condition, very low responsibility, but in dynamic analysis, it has got major responsibility. Okay. And with the same analysis, we perform some remedial measure. What we can do, suppose there's a resonance condition developing with the existing building, what we can do? Suppose there is an existing structure and they are suffering with a resonance problem. Okay, so different alternative analysis we did. Original building without remedial measure. This is original building, ground plus 2 story. This is original building, any floor. So what? Another remedial measure, what we do, full length jacketing of the column, right from foundation to top of terrace slab, full length jacketing. But in that case, we have to excavate the ground. Sometimes your client may not permit. So what we do, partial length jacketing above plinth level. Okay, above plinth level, we are doing jacketing. Okay, not below plinth level. So these are some options we can do with software. Okay, and also we try to provide haunches. Haunt, you know what we provide at the beam column junction. Okay, so we try to provide haunches also, and we also provide tie beam. Of course, these all elements are of steel. Okay, ISMB maybe 150, 200 depends on your design. So we provided. We cannot do anything below lintel level, but we can provide tie beam at the lintel level. Okay, so this is also one option we did. So these are the different options we analyzed with the same building, and we tried to find out which option is better one. Which option is better one? Can you guess which one is better one? A, B, C, D, E, F. Which option is better one to improve the performance of the structure?
Sir, I think strengthening is better option.
Yes.
Strengthening is better option, I think, sir.
Strengthening, we have two, full length and partial length.
Yeah, full length.
Full length is, of course, full length jacketing is much more better. Okay, because the tragedy is there. I will show you plan again. The tragedy, what is the tragedy? Practical tragedy, I will. In this, you can see your machine is vibrating in this direction. And in that direction, we have minimum size of the column available. And this practical issue we are not able to solve. We are not able to solve. Actually, your orientation of column must be like this. Your orientation of column must be like this. Because your machine is vibrating in this direction. In this direction, the strength of the column is larger one. But practically on site, this is not possible. This is not possible. You have to orient column always perpendicular to major vibration created by machine. That is practical issue and we are not able to resolve. But if you do jacketing all around it, okay, if you do jacketing all around it, this is existing column, and if you provide 3-inch jacketing, just like we do in repair, rehabilitation and retrofitting, this one is helping you a lot in improving performance of the structure. But it requires a lot of efforts from client also, because we are going in existing building below plinth level, so we have to excavate and etc. etc. A lot of expenses are involved. Okay, so out of this all option, full length jacketing is far better. Second is partial length jacketing. Third one is haunches. When we provide haunch, okay, this one is much better option because it is improving the performance of beam column junction. Okay, so third better option is haunch. The fourth one is cross bracing below plinth level, and tie beam. Tie beam is at last. So this option is at last. The very first one is full length, second is partial length, third one is haunch, fourth one is this one, cross tie below plinth level, and the fifth one is tie beam when we provide at the lintel level. So this is the what study we did at that time, and this one is giving better option. So this was the finding of this work. Types of foundation. Why I told you that looms industry, why it is different? We are installing looms in a building on floor slab. Traditionally, in any book, you will see machine foundation are of this 4 type: block foundation, wall type, pile foundation, and frame type. Out of these 4, not a single is possible in our looms industry. Block type, wall type, frame type, pile, nothing is possible because we are installing machine in building where it is not possible to provide any kind of this foundation, and that is why it is different. That is why it is different. One component I talked about isolation also. Darshan sir, time is permitting us to go ahead.
Yes, sir. To 11:45.
Okay, fine. So I can cover this vibration isolation topic also. It is very interesting. In looms industry, you will see that they are introducing one element in between machine and floor, and that is called vibration isolating material. Okay, so it is essential to isolate the machine from the foundation so that surrounding structure are not getting affected by the vibration. So such a mechanism we have to install. But in our looms industry, we are not installing spring. They are installing rubber pad or some material like they are saying NAMDA. Okay, NAMDA. So that is what they are installing below the leg of the machine. So why we do vibration isolation? There are 2 types of vibration isolation: active isolation and passive isolation. Active isolation means we are stopping the transmission of vibration from source only, and passive means we are protecting something. Passive means we are protecting something. Okay, so this is what active isolation. We are providing trench. We are providing trench on all 4 sides of the machine so that the vibration will not get transmitted to the adjoining structure. So this is called active isolation. Prevention at the source, and this is we are curing. Okay, so this machine we want to protect, so we are providing trench so that the vibration coming or developed by the surrounding instrument will not reach to this. So this is called passive isolation. This machine is not creating any problem. Adjoining machines are creating problem. So we are protecting it. So it is passive isolation. Okay. So this is what source active source isolation are different name of it: shielding isolation and source isolation. Source is active, shielding is passive. So here you can see the machines are installed on spring so that vibration will not transmit to the other part of the building. Here, machines are not installed on the spring, but the objects we want to protect are having the spring support so that vibration will not transmit to them. So this is what? Shielding isolation, passive isolation. And this is active isolation. Most of the case we are doing active isolation. Okay. Most of the time we are doing active isolation. So this is what we are doing actually. What we are doing physically, practically on site. Machine leg directly fixed with the floor. You can see 4 number of bolt, 1, 2, 3, and 4 somewhere on the back side. Okay. So if now what happened? See, you can see there is no isolating material in between. Your machine leg is directly connected with the floor. Directly connected with the floor. If machine is rigidly connected with the floor, the vibratory movement of the machine itself may be reduced. We are doing this. આપણે ગાડીમાં બહુ અવાજ આવતો થઈ જાય તો શું કરીએ? We just give it for service if it is very noisy, your vehicle. And that in that garage, what they are doing, they are just tightening all the screw of your bike so that it will be less noisy. Okay. The similar thing over here, if you tightly connect this leg of the machine with the floor, of course the vibration of machine will reduce. But what happened? There is a firm contact between machine leg, firm contact between machine leg and floor. All the vibration will transmit it to the floor directly. So machine vibration reduced, but the building vibration will increase. Okay. So that is. Now what if you introduce vibration transmitted to the building will reduce, but your machine itself will vibrate more, and it may disturb the labor operating on it. Okay, because this flexible support, you can imagine yourself standing on the spring. You can imagine yourself standing on the spring. Okay, or you can imagine that our train bogie, which is supported on spring. Okay, your wheel is moving firmly on the track, and the bogie is moving. Okay, the coach is moving. It is vibrating a lot. Why coach is vibrating a lot? Because it is mounted on spring. It is mounted on spring. It means that your train wheel will be firmly connected. It will remain firmly connected with the track. There will not be any disturbance. But the people sitting in the coach will feel vibration a lot because there's a good spring flexible support between wheel and the coach. The similar condition over here, this flexible support is helping you in preventing the transmission of vibration, but your machine is vibrating a lot, and it is not good condition for labor who is working on it. So what we are supposed to do, we must compromise in between. Your machine should also not vibrate, and your building also should not vibrate much. So that is what we call compromise between these two. So we must develop some compromise in between these two requirements. Okay, and that is what we do in power looms. Okay, in context of power looms machine. So this is again, this diagram is given in the book by Srinivasulu Vidyanathan. Okay, in book for machine foundation. In that diagram is given. Excellent diagram it is given. You can see the machine leg. Okay, this machine leg is supported by the pad below. You can see rubber block. Also, there's a rubber block. There's a rubber block here. Okay, and also there is a visor. Okay, rubber washer. You can see 5 number rubber sleeve. This is rubber sleeve. It means that your leg of the machine is not directly in contact with any component. Everywhere there's a rubber material. Rubber, and rubber sleeve. Not a single part of the leg is connected. Even connection with the bolt is also separated. It is being separated by using rubber sleeve, rubber pad. Okay, what does it mean? Whenever vibration will arise from the machine through leg, it will not directly come in contact with any rigid material, say bolt or floor. It has to pass through rubber material. And when it has to pass through rubber material means there's a vibration absorption will be there. Okay, vibration damping of the vibration will be there, and not much vibration will get transmitted to the floor. So this is very typical, and the on-site, the execution must be like this only. But unfortunately, execution on site is not happening in this way. That is reality I have seen on the site. they are putting this rubber block below the leg of the machine, but they are not thinking of this 2 number and 5 number. You will never come to see these two component around the bolt and at the top of the leg. You will never see. Okay, this component you are able to see. Okay, so that I will show you practical diagram. So this is one of the diagram. You can see live photograph of the machine, the Looms machine installed on. What you are able to see, what is this? What is this? This component I am talking about. What is it made up of? How it looks? How it looks?
Wood.
Wood material.
Wood.
It is one of the material for absorbing the vibration, but this is wrong application in case of looms industry, because the looms when this loom is operating, whatever vibration created, the wood material is not that much soft that it will absorb. So here it will just act as a transmitting medium, nothing else. It will act as transmitting medium, nothing else. It will not absorb, definitely. Because when it will absorb, say your bike, when it is able to absorb the vibration, when your jumper is able to compress, when the jumper of the bike is able to compress, then and then it is some energy will get consumed in compressing the jumper and it will not come to you. That is what performance of the jumper. The same thing here. The weight of the machine of vibration is not able to compress the wooden or timber material. How it will absorb? It is just acting as a transmitting medium. Then other application, this, okay. Vibration isolation material, never. Your floor is made up of concrete. This component is made up of concrete. So it will not help you at all. So these are the mistakes you will see, because they are not appointing any engineer. They are just manufacturing. The client is just buying from manufacturer. They are just installing on the site. And what happened after some days or some month or after 1 year, they come across all this difficulty of vibration. They call upon structural engineer that we are feeling vibration. Okay, and when you go to the site, you see the condition is like this. Okay, so that is unfortunate part of this. Okay, also what you are able to see, a lot of spilling of the oil. I have seen they have one expert of the machine. Every looms industry have expert of machine so that they can solve the problem on occurrence of the problem. And he is always working with that oil kupki, what we say. Whenever some noise is there, just filling up the oil. Excessive oil they are adding in the machine. Now what happened? The excessive oil comes onto the floor. Now, why I'm showing this to you? Because it has importance. It has importance. Can you guess why I'm showing this oil to you? Anyone can guess? Can anyone guess it? Why I'm showing you this oil? Spilling of the oil. It is not the oil. Everywhere you can see. Okay. Extra oil just they used in the machine. Okay. Fine. I will tell you. So these are the vibration isolating material they are using. Okay, this is they are calling as NAMDA. They are just calling as NAMDA. Their language, I don't know. That is the language of clients, and this is rubber pad. Okay, more commonly available nowadays. So these two different material they are using below leg of the machine. There is no problem with this material, but this material, many people are using this material. Now, what is the problem with that material? Now, how vibration isolating system work? Let me show you. So this is leg of the machine. This is NAMDA, what I told you. They are providing below, and wooden block. There's a wooden block. So these two systems they are using, wooden block and NAMDA is there. Okay. So these two components they are adding below leg of the machine, and thereafter bolting done directly to the slab. You can see. So this bolt is directly anchored into the slab and not over here. So they are just fixing it. Okay. So this is the mechanism you are able to see in almost all looms industry. Okay. Now what happened here? When push, earlier I explained you push and pull effect. So when there's a push effect like this, when leg is pushing, it has push effect. What happened? there will be a resisting force. Okay, this will be a force acting on the lambda. Okay, force distributed on the isolating material. Now, under this action of force, what happens? Your lambda will compress. It will get compressed, and it will help you in damping out the vibration. But what happens when there's a uplift force? When there's a uplift force will be like this. Do you think lambda will be helpful to you? Do you think lambda will be helpful to you in absorbing vibration?
No.
No, because of this uplift, the gap between these two will increase, and when the gap between these two will increase, your lambda is not effective, not at all effective. Otherwise, instead of that, what is happening? Because of this uplift force, this bolt will get uplifted, and when this bolt is get uplifted, this bolt is connected directly to the slab. So what happened? In case of uplift, your vibration are directly connected with the slab. Your direct vibration is directly connected with the slab. Only in push effect, your lambda is effective. Not in uplift effect, the lambda is effective. That is I wanted to show you. Okay. So this bolt will be under tension, and it will transmit directly force to the slab. It will transmit. How bolt is able to resist tension? Because it is connected to the slab. It means that your slab is now under loaded condition. Your slab is under loaded condition. Okay. So this is conventional vibration system you are able to see, isolation system you are able to see. Okay. And this is not at all useful to you. Okay. So this is what I wanted to explain you. Now, one more question, one more complaint submitted by client to me, that does the condition of soil matters? Does this condition of soil matters? Anybody? Anybody? The condition on which the building is resting, whether it matters or not?
It matters.
It matters, definitely.
Yes.
Because let me share again one experience. Some of the clients were asking me that there is a problem in our building. It is showing a lot of vibrations, and after 2-3 months, this complaint get null and void. They said, no, now the building is performing well. Now, what is the difference between these two? There is a difference of monsoon season. Before monsoon, in January, February, March, they were complaining that we are feeling vibration. But after monsoon season, after June, July, they said that no, we are not feeling any vibration in building now. So this is because after monsoon, when water percolates into the soil, it reduces the stiffness of the soil. And when it reduces the stiffness of the soil, frequency will change. Because the frequency equation is what? 1/2π√K/m. So if frequency will change, stiffness will change, your frequency will change. So what happens? Your building will get separated from the machine frequency, and you won't feel any vibration. Okay. So this automatic removal of the situation is also occurring many times because of moisture condition. So yes, it is affecting. Seasonal changes in the soil affect the vibration. Increase in soil moisture decreases the soil stiffness, and in turn it will causes reduction in natural frequency of the structure founded on the soil. Okay, so that is what one of the experience shared by the client. But not wait for this weight or moisture condition. We have to remove actually resonance condition permanently. So this is what the layer I didn't add earlier because it is making your analysis more complicated. Okay, so this is forward and backward motion of the lay. So this lay is moving forward and backward. Okay, so when lay is moving forward and backward, 0 to 180 and 180 to 3, each and every analyze the building further. You can analyze the building further. You can see so many analysis file you have to run. Okay, so many analysis file. So this is effect of phase angle. What we understood that in single building, this machine is forcing in this direction and this machine is forcing in this direction. The phase angle will be 0 here, and here phase angle will be 180. 180. 0 means your lay is on this side. 180 means your lay is on this side. Means all the machine here are on right hand side and all the machine over here are on left hand side. Motion is on the left hand side. So phase angle also you can add. Frankly, I have not performed this analysis. So further, if you want to study, you can extend the study by considering different phase angle also. So that is phi component. In my study, I consider 0. Okay, in my study, my students consider it 0. So this is what layer of effect of the phase angle. Okay, thank you very much to my esteemed audience for listening me.